Okay, in this video, I'm going to be taking you through all of these area and gradient kind of graphs. Now, these are the ones that tend to be kind of like distance time or speed time graphs, and they tend to be curved, and it's about either finding the area underneath them or the gradient at particular points. So this is not to be confused with these sort of real life graphs. These are slightly different because they all have this idea of finding the area or the gradient of a smooth curve. So all you need to know for this is that if it is a distance time graph, then the speed is estimated by finding the gradient. So I'm just going to jot that down, that for a distance time graph, I'm going to make the pen a little bit thicker, for a distance time graph, I'm going to say that the gradient is equal to the speed. So I'm going to try and find out the gradient at time equals 5 seconds. Now, in order to do that, you have to draw on a straight line that's a tangent at 5 seconds at that point that I'm aiming for. So I think it's probably going to be something a bit like this. I might need to move it so that it just touches it at that point. That's what we mean by a tangent. And then all we're going to do is find the gradient of this line. So I'm going to try and find out how long this part is and then how long this part is along the bottom. So my estimate for the speed for these marks we're going to have here, this looks like it's 0 all the way up to, well, if this is 20, each square is 4, so I'd say that's 72. So this is a 72. So it's the change in y, or the change in the distance, divided by the change in time, which is 5 seconds to go from 3 to 8. So 72 divided by 5, I'll whack that on the calculator. 72 over 5, or 72 divided by 5, is 14.4. So I'm going to estimate that the speed is 14.4, and the units are going to be meters per second. Meters per second. Now let's see what we have for the answers here. They will have anything between 11 and 19, and that will really just be depending on how the tangent is being drawn. So as long as you've got your tangent drawn, they're actually going to give you a broad range of things, but it's only going to let you have that if you get it from the gradient of a tangent. So if you do it in another method and you still get something between 11 and 19, you will only get the mark if you have a tangent drawn on the graph. Okay, this time we have another distance time graph, so it's going to be another estimate of the speed, and this time it's at 6 seconds. So I'm going to try and draw a nice long line that's going to match at 6 seconds. So about at 6 seconds, I would say there. And you always want to make it just as long as possible. You can move it with a ruler to see how it should be done. So I would say that the bottom part of this triangle that we've got here, well, that looks like it's going from 2.5 to 8.5. 2 to 8.5 is 5 long that we've got there. And then this part of the triangle is going from 0 all the way up to, well, this is 15 and 20, so it's 2 squares. So it's about 19.5. So I'm going to say that in this case, the speed is going to be the 19.5 divided by 5. And as before, they're going to give us like a range of values that they would accept here. So if I do 19.5 over 5 and we get 3.9, and again, I think it's going to be meters per second. So 3.9 meters per second. Let's see the answers here. So they've said 3.4, but you'd get anything between 3.05 and 3.7. So I don't think they like the way that my tangent has probably been drawn. I think this is probably going to be a bit easier if I was going to do this on a like a piece of graph paper. Oh, no, I know why I've done it wrong, because I've done something very stupid. To go from 2.5 to 8.5, that's obviously not 5. I am filming this on a Friday after school, so you can see I'm a bit tired. So it's actually a 19.5 divided by 6. It is 6 along the bottom. So let's just quickly change that. 19.5 over 6, and we get 3.25. Much more reasonable kind of answer. 3.25. So you can see I'm doing these in real time, so if I make a mistake, that's what's going on. So anything between 3.05 and 3.7, great, we would have that answer. Okay, so this question is a speed time graph, which means it's got a couple of different features, and this is going to come up for the next few questions. In a speed time graph, the gradient is equal to the acceleration. ACCELR, there we go. And the area underneath the curve is going to be equal to the distance which is travelled, okay? So let's have a think what this question says. It says work out an estimate for the distance the train travelled in the first 20 seconds. Use 4 strips of equal width. So when I go to 20 seconds, I want to find out the area all underneath here. And I'm going to do that with 4 equal strips, which means if I want 2 equal strips, I would say I'll draw a line at 10. And then I'm going to just split those strips into some equal ones as well, like this. And I'm going to try and find out the area of all of these different shapes. I'm going to find the area underneath all of these different sections here. So In order to do that, I have a triangle and then I have 3 trapeziums. Now we know the area of a triangle is just base times height over 2, but I'm just going to remind you that the area of a trapezium, if this was what my trapezium looked like, where this is A and B and this is the height, it is a half bracket A plus B H. Now it might be helpful to have some values on here for these lines. In fact, we'll do the values along the bottom. Each of those gaps are just 5. And then as we go up the side, because each little square is worth 0.5, this is 2, this is 5, this is 10, and then this is 15, 16, 17, 18. So we're now going to try and find out what the distance travelled is. Now first of all I have a triangle, which is just 5 times 2 divided by 2 because it's a triangle. Now the next part is going to be a half. It's the 2 plus the 5, and that's multiplied by the height, which is 5. The 2 and the 5 are the A and B. Now for the next one, the 5 and the 10 are going to be the A and the B. So it's a half, 5 plus 10 times by 5, and our last one is a half, 10 plus 18 times by 5. So we'll get that all in the calculator, and then we'll see if we've got it right. So we're going to do A, first of all, 5 times 2 divided by 2. And then for the next part, we're going to type in all of these little fractiony bits, not a times, sorry, brackets, half, brackets, 2 plus 5 times 5. A half, 5 plus 10 times 5. A half, 10 plus 18 times by 5, and we get the answer 130 metres. Now it says, is our answer an underestimate or an overestimate of the actual distance the train has travelled? Well, if you look here, and it's not so good at this bottom part, but for this part, and this part, we've actually calculated above the black line, we've calculated some extra area in our one. So because of the shape of the curve, our answer is going to be an overestimate. So our one is an overestimate, and the reason we're going to give is we calculated the extra area above the curve and below the trapezium line. We calculated the extra area above the curve and below our line. So let's double check we've got this right. We've got the 130 here, and ours is an overestimate, something about the area of the trapeziums and the curve is also included. Our reason would definitely be good enough for that one. So we've got another speed time graph. It says the graph shows the speed of the car in meters per second during the first 20 seconds. Work out an estimate for the distance travelled in the first 20 seconds using 4 strips of equal width. So very similar to before, we'll do some straight lines at all of these different points that we've got here. And the first one is going to be a triangle, and then we have a trapezium, and a trapezium. You can see this time it's going to be an underestimate because all of them have gone down. So I think this looks like it's a 22, this looks like it's a 28, this looks like it's a 32, and this looks like it's a 35. So if I'm going to work out what I think the distance is going to be with all of these bits along the bottom with 5s, I'm going to say that the distance is a 5 times 22 divided by 2. We've got a half of a 22 plus 28 multiplied by 5, a half of a 28 plus 32 multiplied by 5, and a half of a 32 plus 35 multiplied by 5. So let's just get that all in the calculator. I'll see if I can do that by just actually editing this one that we've got here. So there's a 32 and a 35. Instead of a 5 and a 10, we've got a, what is it, a 28. Oh, it didn't let me go inside that one. I'll tell you what, we won't be doing this, we'll just quickly clear it. So I'm going to do 5 times 22 divided by 2, a half, 22 plus 28 times 5, a half, 28 plus 32 times by 5, a half, 32 plus 35 times by 5. And we get an answer of 497.5 metres. It then says, is it an underestimate or an overestimate? And we're going to say this time it's going to be an underestimate. And you can see clearly here there's extra area underestimate. There is additional area above our shapes that hasn't been counted for. Our shapes that has not been included. So the true area is obviously going to be bigger than this. So let's double check we've got this one. So we've got something that's inside that range, so we've definitely got that, and an underestimate that we've not included parts below the graph, so that's completely fine for this. Okay, this time we have another speed time graph. A car moves from rest, so it starts with 0 here. The graph gives information about the speed in v meters per second and the car t seconds after it starts to move. Calculate an estimate of the gradient at t equals 15. So there is t equals 15. I'm going to draw a straight line at t equals 15. I think that'll be fine. And I'm now going to just work out what these side parts are of this triangle. So if I imagine a side part here and a side part here, well, along the bottom it's nice and easy, it's just 10. Along the side it's going from 15 to, what's that, 21.5. So if I do 21.5, take away 15, that is a 6.5. So all I need to do for the estimate of the gradient, I'm going to say that the gradient is going to be 6.5 divided by 10, which is 0.65. And it says, what does it represent? Well, if you remember on this page here, we said that the gradient represents the acceleration. So we can just write down here that the gradient, it represents the acceleration. Work out an estimate for the distance the car travelled in the first 20 seconds of the journey. Again, we're going to do this again. Geez, they want us to do this a lot of times. So I'm going to draw in, this time I'll do it in red to make it clear which parts I'm looking at. Doesn't look like we're going to have to do any underestimates or overestimates, and it looks like we have a triangle, a trapezium, and a trapezium. So the lengths of these lines, that's going to be a 4, that's going to be a 12, that is going to be an 18, and for the last one, that is actually going, although I haven't drawn it very well, it's going all the way up to 20. So I'm going to go straight in with my distance. I'm going to do part B up here. I'm going to say that the distance is a half, or not a half, we can do 4 times 5 over 2, a half brackets 4 plus 12 multiplied by 5, because all of these distances along the bottom are 5. We've then got another half, 12 plus 18 times by 5, and a half, 18 plus 20 multiplied by 5. Okay, I'm going to see if I can do this a bit speedier. So this time I'm going to do the 4 times 5 divided by 2. Now I'm going to be lazy. Instead of typing in a half, I'm going to do 0.5, and instead of typing in 4 plus 12, I'm going to do 16. So I'm going to do 0.5, 12 plus 18, that's 30, and 18 plus 20, that is 38. So we get 570 meters. So you can see different calculator techniques to be speedier if we need it. So they have said 0.83, but they'll accept anything between 0.6 and 1. So ours is perfectly fine there. We've got that it's the acceleration, and they've said 220. We've got 570. What have I done wrong here? I don't think I've done anything wrong. We've got 10. Maybe it's my calculations again. How odd. I must have typed something in wrong in the calculator. Oh, here it is. At the very beginning, I hope you noticed this, me being way too speedy, I typed multiply. It should have been a plus, and then we get the answer 220, which is what they were looking for. So I did the working right. I'd have lost 1 mark for that bit. So this actually is 220 meters. My apologies, but as you can see, I am doing these videos in live time. So this time nothing curvy, but we have got something else about the distance underneath. It says, here is the speed time graph for the train journey between 2 stations. The journey took 100 seconds. Calculate the time taken by the train to travel half the distance between the 2 stations, and you must show all your working. So first of all, what I'm going to do is I'm going to find the total distance, and the total distance is going to be the area. And so the area is this time a different kind of trapezium measurement. We're going to say that this bit at the top is A, this bit along the bottom is B, and then how high it goes up is the height. So we're going to do the half, and A in this case, from here to here, that looks like it's going from 30 to 80. So A is 50, B is going to be 100, and the height is going all the way up. That looks like it's 10, that's 11, that's 12. So I'm going to just quickly put that on the calculator. I'll do my quick method. So that's a half, 150 multiplied by 12. So the total distance is 900 meters. And they've said find the time taken to travel half the distance. So half the distance, half of 900 is 450 meters. So I need to find out how far 450 meters is going to be. I'm now going to do this by thinking about what areas I do know about. So I'm going to begin by thinking, what's the area of this little triangle part that I've got? Well, it's a 30 by 12 divided by 2. So the triangle that we've got, the area of that part is 30 times 12 divided by 2. 30 times 12 divided by 2, it is 180 meters. So I'll do 450 take away 180 and find out how much extra there needs to be. So if I do 450 take 180, 450, what is going on with this calculator? 450 take away 180 and we get 270 meters. So I want the area of this next rectangle to be 270 meters. Well, I can think, if I want the area of the rectangle to be 270, well, I know that the height of it is 12, and I want to find out what the time is along the bottom. So the time is going to be 270, the area. If I divide it by 12, it will tell me how much extra time there is along the bottom. So 270 divided by 12 is 22.5 seconds. So the total time that it says to travel half the distance between these two stations, well, there was 30 seconds and 22.5. So the time is going to be 30 plus 22.5, which is 52.5 seconds. Okay, part B of the question, compare the acceleration of the train during the first part with the acceleration during the last part that we've got here. Well, you can see this one and this one. The second one is steeper than the first one, which means it was accelerating at a higher rate. So I'm going to say that the acceleration or the deceleration at the end was at a higher rate than the acceleration at the beginning. Okay, let's check and see all of these answers. So we have our 52.5 and then that little worded bit. So we've got the 52.5. The acceleration during the first part is positive, but during the last part it's negative. They would let you say the acceleration is greater during the last part than during the first part. Great, so we've got loads of different things. Ours would definitely get an answer. Wants us to work out an estimate for the distance the car travelled in the first 30 seconds. So because it's just an estimate, they don't ask us to do any number of strips or anything. I think we're just going to go to this 30 seconds. I think we're going to just draw in a triangle and we're going to find out the area of that. So for part A of the question, we're going to do an estimate of the distance. The distance is simply going to be 30, the base, multiplied by the height. It looks like it's going all the way up to 9. 30 times 9 divided by 2. And that is 135 meters. And now we're going to see what it says for part B. It says, is it an answer an overestimate or an underestimate? Give a reason. So our one is an underestimate because there's extra area we haven't accounted for. Underestimate, there is extra area above our triangle, above the triangle that we haven't taken account for, but that will be enough, whatever it's in there. Julian used the graph to answer the question. Work out an estimate for the acceleration of the car at the time 60 seconds. Here is Julian's working. He did speed times time. So he took 13, which is the speed, and he divided by the time, which is 60. Julian's method does not give a good estimate for the acceleration at time 60 seconds. Explain why. He should have drawn, like we've done in all these previous questions, he should have drawn what I've just gestured. He should have drawn a tangent. So I'm going to say he should have drawn a tangent at 60 and worked out its gradient at t equals 60 and worked out its gradient. Okay, let's double check we have these. So we've got 135 underestimate. So yeah, 135 would be in there. It's an underestimate and he has not used or drawn a tangent. So that's perfectly good there. Here is a speed time graph showing the speed in meters per second of an object t seconds after it's first started to move. Using 3 trapeziums of equal width, work out the estimate of the area under the graph between t equals 1 and t equals 4. So there is t equals 1, there is t equals 4. 3 trapeziums are just going to look like this, and the same old stuff with the areas being underestimates or overestimates. Oh no, they don't even ask that. It says what does it represent. So this is a gap of a 1, and a 1. This is a 4, this is a 6, this looks like it is a 7.2. And our last one, if you look at the true one where the black line is, I think that is a 7.8. So we just got 3 different parts here. I'm going to say that the area is equal to a half 4 plus 6 times by 1, a half 6 plus 7.2 times by 1, and a half 7.2 plus 7.8 times by 1. Now I'm not going to do any of the ones because I just think we don't need them. So it's going to be a half times by 4 plus 6, which is 10. So it's a half times 10, plus a half times by 6 plus 7 times 6 plus 7.2 is 13.2. And then for our last one, we've got a half times 7.2 and 7.8, that's 15. So that's a half times 15, and didn't need to do any of the ones there. So our answer is 19.1. What does this area represent? We're going to say the distance travelled between 1 and 4 seconds. Let's check this. So we've got 19.1 at this point, and it's the distance travelled. Great. The diagram shows part of this graph. Now we're looking at quadratic graphs, but it still kind of applies here. P is the point on the graph where x equals 2. Calculate an estimate for the gradient at this point. So x equals 2. We're talking about this part. We're going to try and find an estimate for the gradient by drawing in a tangent. Now I'm going to try and do my best of a tangent here. I can always move this. You could do it with your ruler. Now I'm going to try and work out what these sides of the triangle are. So that side's nice and easy. That side is just a 7. This bit we'll need to be a little bit more careful about on the bottom. So it's going from a 4, that looks like a 0.6. So if I just quickly do a 4 minus 0.6, that's a 3.4. So it's 3.4 along the bottom. So I'm going to do my estimate of the gradient. It's the change in y over the change in x. So I'm going to do 7 divided by 3.4. And we're going to just say 2.06, and I've done that to 3 significant figures. Let's see how that went. So they have said anything between 1.6 and 2.5, and yeah, that's definitely in that range there, and they wanted to see a tangent. Last question, I believe, is about the flow of water. It says the graph gives the volume of water in litres in a container at time t seconds after the water started to flow out of the container. Using the graph, work out an estimate for the rate at which the water is flowing out of the container when t equals 12. Well, when we use the word rate, and you'll come across this a lot more at A-level, it's really referring to the gradient of the graph. So we're going to be finding the gradient when t equals 12. So t equals 12 would be along the bottom. So we're going to try and draw a tangent at this particular point. So I'm going to do my best to draw a tangent. Okay, so what we're going to do is find out the estimate for the rate. Well, let's try and do the gradient. So that looks like it's about a 28. And then along the bottom it is 30 seconds. So if I work out the gradient, I'm going to do the 28 divided by 30. 28 divided by 30. I'm going to say that it's 0.93. We'll do 2 decimal places, they didn't ask, but that will be fine. And it says use the graph to work an estimate of the rate at which it's flowing out of the container. So I'm going to say that it is 0.93. Look at the units we've got. It's litres per second. 0.93 litres per second. Let's see how this one goes. So they've given us anything inside this range, a tangent there, and yeah, that's all we needed to do. So they've even suggested what we did, 28 divided by 30. So that's all the questions that have got these kind of areas and gradients. You'll see how they're a little bit different to the real life graphs that have appeared earlier on. And that's also everything in geometry and measures. So I'm hoping this is going to really help you with your exams. If you found this useful, please do just drop the video a like, share it with any of your friends, and stay subscribed if you want to get any more updates.